Welcome everyone. Today we're going to be looking at a branch of chemistry known as stoichiometry. As you can see, stoichiometry is the study of quantities of materials consumed and produced in chemical reactions. In other words, they are mathematical relationships between the components within a chemical reaction. One of the most simplistic stoichiometric problems is known as a mole-to-mole problem. In fact, this problem can be solved in one step. I have a different way of teaching this. Whenever you read a question, what I recommend you do is label the given in the question, what is given to you, with the letter A. And then whatever they're asking you to solve for, or the unknown, label it with the letter B. Now, when you do this equation, you're going to be given the moles of A, and then what you're going to do is you're going to multiply by B over A, and you're going to get the answer, which is moles of B, or the unknown. The question is, what exactly is B over A? Well, B over A is known as the mole ratio. And the definition of the mole ratio is that it comes from the coefficients of a balanced equation. You see, you're going to be given a chemical reaction. If it's not balanced, your job is to balance it first. If it's already balanced, that saves you a step. From that balanced equation, that's where you obtain the coefficients that make up the mole ratio. Let's take a look at an example. Here you got sodium chloride being formed by reacting sodium and chlorine. The question says how many moles of NaCl result from the complete reaction of 3.4 moles of chlorine. Assume that there is more than enough sodium. When you read this equation, they want to know how many moles of NaCl. That is the unknown. So look what I'm going to do. I'm going to label that with my letter B here. The unknown is NaCl, and we're looking for moles. Now, what is given to us in this question? According to this, we have 3.4 moles of chlorine. So let's label chlorine here with the letter A. And we have 3.4 moles of it. To solve this, here's what you do. You get the moles of the given, which is chlorine. Okay, we'll call that moles of A. So you go 3.4 moles of chlorine. And then the mole ratio, this equation's already balanced. So look how you obtain the mole ratio. Look at the coefficient of B. It's a 2. Look at the coefficient of A. When you don't see anything there, you assume it's a 1, because it is a 1. So B over A would be 2 over 1. Now, what does this really mean? It means that you got 2 moles of the unknown, which is B, over 1 mole of the known, which is A, and that will cause these to cancel. So the math is actually pretty easy. When you multiply 3.4 times 2, which is the mole ratio, you're going to get the answer, which is moles of B. In this problem, B happens to be NaCl, and you're going to end up getting 6.8 moles of NaCl. And that is the answer to this problem, and I rounded it to 2 significant figures. Actually, it comes out to 6.8. Now, here's another mole-to-mole problem. I would like you to try this problem. The equation, if you look, it's already balanced, so that's going to save you a step. So go ahead and perform this mole-to-mole problem. Pause the video, and when you're ready, return, and we'll work it out together. Okay, so I am assuming that you completed this practice question. So here we got water being formed by the reaction of oxygen and hydrogen. They're asking us how many moles of water. So water is going to be our unknown. Formed from the complete reaction of 24.6 moles of oxygen. So oxygen is our given here. And it's 24.6 moles. It says assume that there is more than enough hydrogen. Hydrogen is not part of this stoichiometric problem. It's a mole-to-mole problem because you're given the moles of A, which is oxygen. And in order to do a mole-to-mole, it's a simple one-step problem. We're going to multiply by the mole ratio to get the moles of our answer. So let's substitute. The moles of the given is 24.6 moles. The given is oxygen. The mole ratio is the coefficients from the balanced equation. Here is B, and there's a 1 here. That's A. So the mole ratio is 2 over 1. When you do the math here, you end up getting 49.2 moles of the unknown, which is water, and that is already rounded to 3 significant figures. Okay? Now, you might also have a mole to mass problem. And if that's the case, you do the same thing we just did, but you have to do an extra step. They don't want the answer in moles. Sometimes they want the answer in mass, usually in grams. So if you're doing a mole to mass problem, the extra step is to go from moles of B to the mass of B, or the unknown. What you need to do is you need to find the molar mass of whoever that unknown is, of B. And you have to multiply by that molar mass. Okay? So this is what we call a mole to mass problem, and that's the extra step. Now, you might be asked to do a mass to mole problem. Again, here's your mole to mole equation or flow chart. If it's a mass to mole problem, you first have to convert the mass of the given into moles. You see, this piece right here that lets you go from A to B, I refer to this as the bridge. And in order to go from the given to the unknown, you have to be in terms of moles. So if you encounter a problem where you are in grams or kilograms or any other unit of mass, usually grams, you must convert to moles. And to go from grams to moles, you simply divide by the molar mass of the given, and that will convert you to moles of A, and then you can simply multiply by the mole ratio to get to the answer. So that would be an extra step. Now here's what I'm going to do. One of the most important stoichiometric problems in chemistry that you need to master is how to do a mass-to-mass problem, which includes these steps that I just referred to. In a mass-to-mass problem, you're given usually the substance in grams. So first you got to change it to moles by dividing by the molar mass of the given. Once you're in moles, you multiply by the mole ratio, which is B over A. That takes you to the moles of the unknown, but they don't want the answer in moles, they want the answer in grams, so you have to do an extra step here. You have to go from moles to grams. This time you're going to multiply by the molar mass, but you're going to use the molar mass of the unknown. Now, something very important, I'm going to put a little asterisk here. And I'm going to write something for you here. One of the most common mistakes that students do is they use the coefficient as part of the calculation of molar mass. So I'm going to write this down as a reminder, and I will mention this repeatedly. Never use coefficients to calculate the molar mass. This is extremely important. The only time that you use coefficients is for the mole ratio. So whenever you're being asked to find the molar mass, ignore the coefficient. Okay, for instance, let's say you had 2 waters. When you find the molar mass of water, you ignore this. You have 2 hydrogens and 1 oxygen, not 4 and 2. Okay, so you ignore the coefficient. You simply look at the formula. The subscripts you include, okay, there are 2 hydrogens there and 1 oxygen, but you do not include the coefficients when finding molar mass. So let's do the following. Here we have a mass-to-mass problem. It says, this is a photosynthesis problem. It says plants convert carbon dioxide and water into glucose according to this reaction. You're probably familiar with this from biology. The question is, how many grams of glucose? That's mass. Glucose is way over here. I'm going to put a B here because that's my unknown. Notice they want grams. So they want the mass of glucose. So what's given? 58.5 grams of CO2. They do mention there's more than enough water present to react with the CO2, so water is not important. Our given here is carbon dioxide. And according to this, we got 58.5 grams of CO2. Now, I'm going to take you through the steps. What you're going to do first is we need to go from the mass of the given, which is A is CO2, and we got to change it to moles. According to the flow chart, you're going to divide by the molar mass of A, which is CO2. Now, you are going to ignore that 6. You're only going to get the molar mass of carbon dioxide. There's 1 and 2 of these. Okay, 1 carbon, 2 oxygens. This is 12.01. This is 16. That gives you 32. 12.01 plus 32 gives you a molar mass of 44.01 grams per mole. So the first step is to get the mass of the given, which is 58.5 grams, and divide, and we could just do it like this. You could use this or dimensional analysis. And you're going to convert it into moles. I end up getting 1.32924. There's more numbers. At the end, we only need 3 significant digits. This is moles of A. A is CO2. Now, once you're in moles of A, now we're going to cross the bridge. Now we're going to multiply by the mole ratio so we can get moles of the unknown or moles of B. The mole ratio here, if you look at the coefficient of B, it's 1. The coefficient of A is 6. So the mole ratio is 1 over 6. So if you divide that number by 6, you get 0.22154. And there's more numbers. That's plenty. That's moles of the unknown, which is glucose. Now we got to do one more thing. We got to convert moles of B into mass of B. B is glucose. To do that, you multiply by the molar mass. This time, we're going to use the molar mass of B. So, let's go ahead and do that. Let's see, I got a little bit of room here. So, carbon is, there's 6 of them. Each one is 12.01. When you multiply that, that's 72.06. There are 12 hydrogens. Times 1.01, that's 12.12. And as far as oxygen, there's 6 times 16, which is oxygen, 96. And when we add this up, the molar mass is 180.18 grams per mole. So if we do the last step here, if we multiply by 180.18 grams per mole, okay, the moles will cancel, and this problem had 3 significant digits, so we're going to round it to 3 significant digits, and we're going to get 39.9 grams of glucose. And that is the answer to this mass-to-mass problem. Okay? All right. I want you to try this one. This is a mass-to-mass problem. And here it's already balanced for you. Okay? So go ahead and set this up. Pause the video. And when we return, we'll work it out together. Okay, I'm assuming you did this problem. So according to this, we're making magnesium hydroxide and hydrochloric acid are neutralizing each other, forming water and magnesium chloride. They want to know how much HCl in grams. So this is what we're looking for. let's call it B. And they want it in grams, so that's mass. The given here is we got 5.50 grams of magnesium hydroxide. So this is our given, our A. It's also in grams. So the given is in grams, the unknown, they want it in grams. Therefore, this is a mass-to-mass problem. First thing we got to do is change the mass into moles. Now, what we need to do is we need to find the molar mass of A. So let's do that over here. Magnesium is 24.30 or 24.31, depending on what periodic table you use. There's only one magnesium here, so we'll leave it at 24.31. Now there's two oxygens. Each oxygen is 16. There are two hydrogens. Each hydrogen is 1.01, so that's 2.02. When we add this up, molar mass is 58.33 grams per mole. So step one is to get the grams given, 5.50, divided by the molar mass, 58.33 grams per mole. The G's will cancel. You're going to get 0.09429, and that's going to be moles of magnesium hydroxide. Now we're ready to cross the bridge. Our next step is to multiply by the mole ratio, which is B over A. In this case, it's 2 over 1. So when you multiply by the mole ratio, you get 0.18858, and that's going to be moles of B. B is HCl. What we need to do now is we need to go from moles of HCl to grams of HCl. So we need to find the molar mass of HCl. Again, guys, remember to ignore the coefficient. So there's only one of each. This guy's 1.01. This guy is 35.45. When you add this up, you get 36.46. That's the molar mass, grams per mole. So if you multiply by 36.46 grams per mole, the moles cancel, and we're going to round this also to 3 significant digits. You end up getting 6.8757 and change, but when you round it, it'll be 6.88, and it's going to be grams of HCl. And that'll be the answer to this mass-to-mass problem. Again, remember, never use coefficients when you're finding molar mass. So here we have... just briefly, these are the steps when you're doing a mass-to-mass problem. Remember, check that the equation is balanced. If not, that's the first thing you're going to do. If you're given the units in grams, change everything to moles. Set up your mole ratio, which is B over A, or unknown over known. Once you use the mole ratios, that will take you from the given to the unknown, or from A to B. So once you're in moles of B, if they want the answer in moles, you're done. If they want it in grams, you need to find the molar mass of B. Again, never use the coefficient when you're finding molar mass. You multiply by the molar mass, and you will get the answer in grams. Okay, so those are briefly the steps that you do when you're performing a mass-to-mass problem. Now, you might also have this. I call it mass to particles. And really, the only thing different is the last step. If you look at this problem here, if they give you something in grams, you do what we normally do, change it to moles, okay? Divide by the molar mass of A. And then you do the important part, what I call the bridge. Once you multiply by the mole ratio, that will take you from the known to the unknown. But pay attention to what unit they want. Maybe they don't want the answer in grams. Maybe they want particles of B. And remember, particles is a generic term. Maybe they're looking for atoms of B, of the unknown, or molecules. These are some of the terms that are used often to represent particles. It could be atoms, molecules. You might even see formula units. If you see any of these terms, they're all specific types of particles. So to go from moles to particles, if you recall, what you do is you multiply by a constant known as Avogadro's number. you multiply by 6.02 times 10 to the 23rd, and that will get you to whether it's atoms, molecules, or formula units of the unknown, or B. So that will conclude our first stoichiometric lesson. Practice is going to make perfect. Just always remember it's always B over A, not A over B. That's one common mistake students make. And the big one, never include coefficients when you're calculating molar mass. Good luck with your practice problems.